In this lesson, we'll be looking at arc length and sector area. So remember, a arc is a portion of the curve of our circle from one particular spot to another, just between points. I have it highlighted there in yellow. The measure of an arc, which is what we have been dealing with, the measure of an arc is given in degrees. But the length of an arc needs to be a distance measurement. Inches, centimeters, miles, yards, feet, meters, kilometers, whatever type of distance measurement, but we're telling the actual distance from that point to that point. Like if you were going to be putting paint there, exactly how much paint, how long would that curve of paint need to be? Well, you looked yesterday at a video from Math Antics about circumference and area. So remember, circumference is the distance all the way around that circle. But I don't want to go all the way around. I don't want to go all that distance from there to there. I just want this yellow part. That's it. So we don't want to go all the way around it. We want to go just a part way around it. So to find the length of that arc, we're going to use a formula. So the length of an arc, and here's our formula, it's the arc measure, remember that's in degrees, out of 360. This is going to be a fraction that's less than 1. Our arc might be 90 degrees, 80 degrees, 120 degrees, could be 300 degrees, but something smaller than 360. So 360 is all the way around the circle. We're not going all the way, so we know this is going to be something less than 1. So that decimal 0 point something, we will then multiply by the overall circumference. So we're going to take the circumference, but we're only going to use a portion of that circumference. So let's take a look at our first example. It asks us to find the length of arc AB. I'll come over here and show you the diagram. Here is circle C, and we have a central angle of 100 degrees, and we know that central angles and their arcs are congruent. So arc AB's measure is 100 degrees, but we don't know its length. That's what we're trying to find. So we're going to use our formula from up here, arc measure over 360 degrees, so 100 degrees out of the 360 degree full circle, times the circumference. So how are we going to find the circumference of a circle? Well, yesterday you looked at 2 pi times the radius, which in this case is 3 yards. And that's what we're going to plug into our calculator. So we're going to grab our handy dandy calculator. Yours might not be pink like my daughter's is. It's okay. We're going to do 100 divided by 360. And so we know this decimal right here is 0.27 repeating. Okay? Now I can write that down. I don't really need to because I know over here I'm going to be multiplying that by 6 pi. Where did I get the 6 from? The 2 times the 3. So we're just going to leave this in our calculator without hitting anything else. I'm just going to hit times 6 times 3.14. And we find out that the length of AB, length of arc AB is approximately, and most of these are going to be approximately because we know that pi is approximated to 3.14, so we're going to end up with approximate answers. So we have on the calculator screen 5.23, and the 3 is repeating, yards. So that portion of the circle that connected point A and point B, this distance is going to be 5.23 yards. The second topic for the day is sector area. So a sector is defined to be a portion of a circle. So up here I have this yellow colored in section. This sector is a part or a portion of the whole circle. So the area of that sector will be a portion of the whole area. So it's going to look very familiar. This measure will be some number of degrees. This one might be, I don't know, like 70 or 60 or something like that. We're going to take that measure in degrees and put it over 360, just like we did for arc length. But instead of timesing it by circumference, this time we're going to be timesing it by the area of the full circle. Remember, area would tell me how much space this entire circle takes up. And I don't want the entire circle. I only want that piece of it. But if I find the whole area and then times it by this fraction of the circle, that should lower the area down to only that sector. So here we have circle P, and we are asked to find the area of the shaded sector. So I'm going to take a look at our diagram. I'm going to try and make it so I can see the formula, or at least the start of it. So I want the arc degrees out of 360. So again, I have a central angle. This one's measured 150. If the central angle is 150, then arc RT would measure 150. So 150 degrees out of 360 degrees times the area of this full circle. Area, we learned yesterday, is pi times radius squared. So we know we're going to take this fraction, whatever it is, and times that by 12 squared is 144 pi. So let's figure out what 150 divided by 360 is, so we know what decimal we're going to use there. 150 divided by 360, and we get 0.416 repeating. It doesn't matter really even if we write that down, as long as we keep going. We're going to times that by 144 and times that by pi, or 3.14. So we get the area of this sector, and remember we have to use approximate since we use 3.14, and that in itself is an approximation. And on our calculator screen we show 188.4. And then of course we need units, and in our diagram over here this was centimeters on the radius, so we need centimeters squared. Remember, square units every time that you answer an area question. So your assignment today is to practice 4 of the arc lengths and 4 of the sector areas. Let me know if you have any questions.